Thank you all for attending our webinar today to discover how to use mobile technology to your business advantage. My name is Natalie Musa, and I'm going to run through a few housekeeping items before I introduce our speaker. The webinar itself will be around 30 minutes, followed by question and answer period. If you happen to have a question during the presentation, just type it in the questions box, and we will try to get to them at the end of the presentation. Now I'm going to turn it over to Jeff Griffin, one of our mobile consultants here at Pactera. Hope you all enjoy the webinar. Jeff?
Hi, everyone. First, I'd like to thank you for joining. I think mobile technology is very interesting, and it's one of my passions, and I hope I can share some information with you today that will help you in your business. So as we start to talk about mobile technology, I think we need to really understand the context. And the context of mobile is extremely important. And there are many pieces to today's mobile puzzle. And that, really, the hardware, the connectivity, and the software all combined give your business an opportunity for innovation. And when you innovate, you can leverage those best characteristics and you can build out innovative solutions. So let's talk about some of the baseline pieces of hardware. As we move through this webinar, I'm going to talk about sort of what I call core functional hardware pieces.
Welcome to GoToWebinar.
That are all very critical in sort of determining some of the more advanced mobile systems. So mainly I'm going to talk about the pieces of hardware that exist in smartphones today. And as you all know, smartphones are everywhere, and everybody has a smartphone now. But not everybody understands all the bits and pieces that make up the smartphone and why it works that way. So while these bits and pieces of hardware are interesting by themselves, as a group they are very compelling. With the exception of NFC on this slide, every modern smartphone ships with all these hardware elements. NFC, which we'll talk about later, also ships in a large number of devices today, but does not ship on and is not everywhere. So I'm going to start by talking about each of these technologies in turn. The first one is something that people know they have and they use almost every day, but they don't really know how it works, and that's accelerometers. So accelerometers are a little piece of hardware that shows real-time acceleration across 3D space. Sensor is updated hundreds of times per second, and it's very sensitive and accurate. The accelerometer is always on and is built into the chipsets and is available for all applications. Can gather real on how that device is moving through space, and that's a very useful task. We have several use cases that are somewhat ubiquitous now, and that's switching from mode or even driving your device back and forth. The 3D space and that acceleration happens across all three dimensions. But, you know, use cases apply to this hardware already, one of which is an emergency call or text list. Just through a sudden deceleration, maybe you've got some sort of emergency. Those kinds of things. You can also build your own home security system in a very. You can set your phone by your door, and if it gets nudged while you're not home, then you know that something happened. So those kinds of use cases are built on technology like accelerometers. Moving on to the next piece of hardware, cameras. So a lot of people take pictures with their phones today, and cameras aren't really new news. But in your business, you can use your camera as a scanner or a reader. And QR codes also cost-effective technology, and combined can accomplish a lot of tasks. Cameras also can participate in augmented reality, and that means overlaying information on top of a view that you have through your device camera today. Now, microphones are another interesting case. Everybody has one because everybody talks on the phone, but with applications like Siri for Apple, it's now an interface device to get work done. And there are other use cases as well. It's not only just to record or to send you as a sensor trigger that can be used to wake up your device and then to reissue messaging alerts, for instance, so you don't miss that critical text message when you put your phone down. So moving on to the next bit, we'll talk a little bit about short-range radios. All phones are connected to cellular networks, and they can send and receive megabits per second of information. These are powerful long-range radios, and they're tuned specifically to the cell networks that you see. But today's phones also have short-range radios. These radios work over hundreds of feet, not several miles, and they use much lower energy, and they have lower throughput rates. Most of you already have a basic understanding of how these things work. You can use Bluetooth to listen to your calls on a small headset or play music to your stereo. You can also connect to Wi-Fi to save on data charges. But the impact in this context is that information is distributed on or transmitted on a proximity basis. For instance, Apple's new iBeacon and Samsung's Galaxy Gear provide proximity applications over Bluetooth Low Energy. These key technologies support very long battery life and enable new machine transmission. Let's talk about another very short-range radio communication technology, and that's near-field communications, or NFC. NFC is used today in millions of payments transactions. In Europe and Asia, large deployments of point-of-sale solutions and NFC-enabled devices drive data commerce. In the U.S., the market is mainly fragmented and unclear. Because Apple doesn't ship NFC hardware today, many of the solutions to drive payments don't have enough coverage for mass consumer adoption. But the high-end platforms on other smartphones do have NFC built in, and there are lots of other interesting applications for NFC. NFC less than 10 cents on a wholesale basis, and device-to-device communications are relatively simple. There are already pairing use cases for secure Wi-Fi and marketing applications for product information and fast information transfer over technologies like Google Meet. But closer to home, you can do a lot of interesting parlor tricks with NFC, one of which is tapping to trigger an action on a device like Samsung's Tactiles. These tricks can reduce the amount of time it takes your employees to clock in, for instance, or to pull up relevant product information for a customer, or to start a training video on their phone. Today, you can get a pack of Samsung's Tactiles, which are fully customizable, for less than $10, and you can automate some of your mobile processes. So let's talk about positioning. Positioning is a very talked about technology for phones today. A lot of people know this as GPS, but I'm going to talk about all of the technologies used for positioning, for the positioning system here now. So the first thing a phone does when it wakes up is it looks around to see which towers it can see and communicate with on the radio network. Those towers provide a context for where that phone is globally. Unfortunately, you don't get sort of 3D positioning from the towers alone. You get which tower you're registered to, which is typically a 2 or 3 mile radius. And that's really as good as you get from the towers now without a lot of extra work and specialized hardware. But once your phone looks for those towers, and this happens over a few seconds, you have a relative location of where you're at, which section of the city you're in. And that is pretty good for a lot of applications. But there are multiple stages to this, and the next stage is also interesting. If you've got Wi-Fi enabled on your phone, look around for Wi-Fi hotspots. Now, once it sees a couple of Wi-Fi hotspots, your phone can then position itself to a much smaller area. And this is within a few hundred yards because Wi-Fi doesn't transmit that far. Now, one of the baselines for these technologies is companies like Google and Apple provide databases of information of things like where the towers are and where these Wi-Fi hotspots are. And these are community-driven in many cases, so people who've got Wi-Fi connections and GPS connections transmit their GPS location and the Wi-Fi's GPS location into these databases, and then other people access them for location information. Wi-Fi scanning is also relatively fast and relatively cheap. You can get a fix on your Wi-Fi location in 10 or 20 seconds. But the next stage is the one that people really discuss often. And this is when your phone connects to the GPS network. Now your phone has a receiver that has to see, and when I say see, I mean direct line of sight, the sky to connect to the GPS network. Your phone needs at least 3 of these satellites information received to calculate where it is in 3D space. Now this process takes a while because there are a lot of satellites in space, actually a minimum of 60 per network, and there are multiple networks for GPS location. And when the phone processes that information, it has to wait for the data streams to finish for each of the satellites to figure out where it is relative to the other satellites. Now, this process can take over a minute and is relatively expensive in terms of time and battery use. But you can get extremely good results based on your GPS satellite location, and that's all the way down to a few feet from where you're standing. So as long as you're outside and you have time, GPS certainly provides the best fix. But for many applications, tower-based location or Wi-Fi-based location is good enough for what you're trying to get done. For instance, if you're searching for the nearest pizza restaurant, sometimes tower-based location works fine. So let's talk a little bit about how data access works. Data access has a couple of connectivity options, one of which is wide area network. So that's the cell network and transmitting data over the cell towers. The other which is Wi-Fi, which most people know about already. When your phone connects to the cell network, it receives a different address almost every time. And that means that your phone's kind of shifting around in its location, both figuratively and literally. If you have a service or server on the internet or in the cloud, you can't reach out to that phone unless it connects to you first. One of the ways that manufacturers have gotten around this, and technology companies have gotten around that limitation over the years, is to use SMS triggers. And that's great for when you need to notify the device that something's happened. One of the earliest implementations of SMS triggering was done over BlackBerry. With their email solution, it was both secure and had push notifications so people could get their email in a timely fashion. That was relatively revolutionary back when they began, but now many companies have push notification systems, and we'll talk a little bit about how that works too later. But today, once your phone connects in, you have a choice. You can either pull data from the servers on the phone, which is costly in terms of battery life and data connectivity fees, or you can poke the phone with some sort of text message. Text messaging has been the preferred method for manufacturers and developers of technology over the past 10 years. There are a couple of interesting things about how phones do connect today, though, that are useful in your enterprise. Many of the advanced software platforms have application interfaces that say, hey, I'm connected to the network or I'm not connected to the network. But given that data security and access is controlled at different locations, sometimes you can get a false positive from those application interfaces to your application on the phone. In other words, you can say, hey, am I connected? You can get back a yes, but you may not be able to get out to the internet in general because you haven't signed into the proxy or because you haven't exactly completed the sign up for a new address process yet. And when you do that, your application tends to try to connect, but you tend to leave your users hanging with sort of a no data services available message. Those kinds of user experiences mean that you don't necessarily get the greatest communication with your users on the current status. So one of the things that you need to do to fix that, to check for that, is to make sure that you check a ping service, for instance, to show that you're online before you talk about whether or not your data services are down in your application. Also, moving between these networks is still an opportunity. So in many cases, you may be conducting your, say, data streaming over cell networks to watch a movie. But when you go home, you'll automatically switch to your Wi-Fi network as a preferred provider. When you do that, though, your movie stops and you have to go and you have to restart it. There are still interesting problems to solve in that space to provide seamless connectivity while transitioning back and forth between different types of networks. So let's talk about some of the advanced mobile systems now that we've talked about some of the basic building blocks. And we're going to talk about geofencing and payments and push notifications and routing. Geofencing, most people have heard the term. It's a combination of several different pieces of hardware and systems, including location-based technology and network access technology, which also includes push notifications. Geofencing is actually user and device and app-based. There's not a server that watches where everybody is and sends triggers. And the way geofencing works is when you get close to one of your points of interest, that generates a trigger, and that's an application event. And then finally, you can get events when you move both in and out of one of these fenced zones. So to explain how geofencing works at a high level, you start with your phone and you start with a couple of points of interest. Now these points of interest can be anything that you're interested in or your applications are interested in. Let's say that I'm interested in knowing where my local Starbucks is. Well, in this case, I can register those points of interest in terms of latitude, longitude, radius, the store size. My application can register those in a table that's device-based. Now once that device has that table and this service is activated on the device, what happens is the device builds out virtual boundaries near those points of interest. Now, as a part of the locationing system, the device is going to wake up and check its location via the positioning subsystem. And when it does those things, it's going to say, hey, I'm not near one of these boundaries, and I'm going to set a time to check again to see when the next time I'm approaching one of these boundaries is. Now, since a lot of the information that you need to do positioning costs in terms of battery life and or data, what you want to do is make sure you only check when you need to check as far as your relative position to your points of interest. So that's why these circles have different radii. As you get closer to your point of interest, your period to check for the next time goes down. So if I'm 100 miles away from my point of interest, I might check once every hour to see if I'm getting closer. But if I'm 50 miles away, I might check once every 30 minutes. In that way, these locationing and positioning systems in the phone save time and energy, and they only check when they need to. They're relatively smart about saving battery. Since that position goes down, and when you cross that boundary, you may check once every minute to see if you cross that boundary. Once you cross that boundary, though, then you can get something that's got real context in it. Your application will know that you're at one of those points of interest. It can then access servers and check today's special event for you. In this case, I went into my local Starbucks, and what this application can do is bring up my Starbucks passbook card, and it can allow me to pay at the point of sale. And this is without signing in, swiping, or tapping anything. It knows I'm at Starbucks and I'm ready to buy my coffee. And speaking of payments, there are lots of different ways to pay today. We're going to talk about a couple of those. The first of those is NFC. As we've already discussed, it's a short-range technology that's very secure. Your payment credentials are stored on a secure element in NFC. And to do all of your payments provisioning, you use something called a trusted service manager. Those are interesting, but what it really means is that you can use your Google Wallet here in the U.S. and you can buy things at places like fast food restaurants or stores that support that with their point of sale. They deduct from your wallet, and the payment gets processed through the normal payments backhaul system with our financial institutions. Payments are relatively limited in this country because you can really only get payments to work over the Sprint network today on Android devices. I'll talk about QR codes and scanner next, though. And the QR codes and scanner are actually how Starbucks implemented their own proprietary payment system. So as shown in the pictures, you can see that your QR code is, in fact, shown on the device and read by a point-of-sale scanner that's tied into the point-of-sale systems of Starbucks. That means that they can take your payment information or your identified loyalty information and then subtract money from your account at Starbucks. Now this doesn't use NFC and this doesn't use extremely fancy technology. It has a QR code that uniquely identifies you, and it's got the systems in place to read that scan. That is actually translated into tremendous amount of uptake for Starbucks, and that's because they used innovation to build out their business. Now the next step in terms of speculation is how Bluetooth and iBeacons will affect point of sale. There's a lot of rumors and technology built in to leverage iBeacon and Bluetooth low energy to build a complete payment solution where you won't even have to show a passbook pass to pay. You'll be able to effectively tap and pay standing in line. So, but that's, at this point, that's still speculation, but the point of payments is you can use a lot of different technology baselines to accomplish the same goal. And there's a lot of innovation going on in that space for mobile. So let's talk about one of those other baseline technologies, and this is push notification. So since your phones have to poll because their locations aren't known automatically, that actually led to a lag in distribution of information. One of the first companies to fix that was BlackBerry at the bottom. And what they did was make sure that they could poke you if you had new email. They extended that to the BlackBerry chat service, and those are both very popular applications. Today, all major manufacturers of smartphone platforms, including Apple and Google and Windows, provide their own interfaces to do push notifications in the same way. And when I say notifications and push notification frameworks, I mean your services can connect to Google's servers to send out notifications to your users that something interesting has happened. Each of these notification frameworks do similar tasks, but they do it slightly differently, which means if you want to reach a large device population, you have to implement 4 or 5 different push notification frameworks within your enterprise. But having said that, companies like Urban Airship and Amazon provide proxy services for notification that hit all of these platforms simultaneously. So by leveraging those, you can hit a much greater device audience without having to maintain your own push notification framework interfaces. And as you see on the right, the net impact of a push notification in this case is this notification shows up on your home screen before you unlock your phone. This is the first thing you might see in the morning, and the first thing you'll see when you pick up the phone. And you know, as a marketer, you can understand the impact of that message. This is not something you have to look for. It's something that you have to look away from. So let's talk a little bit about the Starbucks overall case study. They began their mobile path when they built in their mobile payment solution inside the Starbucks app. And this included the loyalty aspects, this included a credit management aspect and a payment aspect. They invested tremendous amounts of money to upgrade all of their point-of-sale solutions with scanners, and they integrated that seamlessly for their app. Then they took the next step, and they added that QR code to Passbook, which was Apple's way to show all of your loyalty cards in one place. Passbook also brought in both push notifications and geofencing, which Starbucks leveraged to the fullest. So today, when you approach your Starbucks, your Passbook pass shows on the phone, it shows your balance, and you're able to pay without even swiping the phone. And the easiest. This is even easier than pulling the credit card. You flash your phone and you pay, and that's very simple. Now the net impact for what they've done is very interesting. So today, 10% of all the U.S. transactions are mobile transactions, and that's built with this platform. They take more than 4 million payments a week using this platform. That translates into more than $3 billion in annual mobile revenue. And believe it or not, because it's faster for you, they get you out of line faster. And that means more customers get served, and you spend less time in line. So that's better for everybody. Now, this is a great example of how you do both business strategy and technical innovation at the same time. They did place some big bets. They did invest in point-of-sale scanners. They did invest in the infrastructure to put this out there. But they built some excellent value and a key differentiator for their business. So we need to talk a little bit about how you get your data in a secure way from your backend servers out to the devices themselves. Mobile is great, but mobility has some security concerns, one of which is device security, and that's physical device security. It's easier to lose your phone. Another of which is mobile data security. If you don't have access, if you've lost your phone, what can people pull off of it to use against you? And also, what about the data in transit? Well, because information is key in the information age, there are many mobile technologies that support both secure transfer of information as well as securing that information at rest in the device. So good technology and Zen Mobile from Citrix both provide great platforms for securing your information in transit and securing your information at rest. And along with that, they provide full device management suites, which control things like device wipe and lock. If you've lost a device, they can erase the key data from it, and they can lock it, and they can manage your software upgrades as well. So we're going to spend a little bit of time on routing. Not a lot of time, but a little bit of time. And this is one of the oldest use cases for mobile positioning. And this is how you get from point A to point B. Yeah, this is more than a decade old, and it's not that interesting. But I'll build a baseline here because I've got a point in a minute. So this really uses exact GPS positioning to get you down your street to the next street. It also includes map data, which of course has advertiser opportunities from companies like Google. It builds out some pathing, which is sort of the best route to get from your point to the next point. It can add in some points of interest along the way. And some of the later apps today have live traffic feedback. And that's the best way to get you from point A to point B now, information that does save you time on a daily basis. Not that that's new, but the next interesting piece, though, is how companies have used this to innovate. So I want to talk about a company called CEMEX. You might think that cement is a commodity good. And you might think that trying to deliver cement in the late 90s and somewhat rural Mexico across roads and infrastructure that were uncertain would be a relatively tough task. Well, you know, innovation can happen in the strangest of places. And CEMEX is Cement Mexico. And what they did was they understood that their deliveries were late. They understood they had a lot of waste, because if you don't get the cement to the right place at the right time, it actually goes bad. You have to dump that load. They understood that their customers were not getting what they needed, and they were effectively they were putting out fires every day in almost an emergency room-like basis. So they took a look at how they could update their business strategically. And what they did was they understood that instead of doing sort of a demand-supply run, in other words, customers called up and said they needed cement by a certain time, because they could not predict how long it would take them to get there. They were going to run into the same process. They flipped it around, and they played a supply-demand chain. And to do that, they knew they needed certain pieces of technology, one of which was GPS and routing. So they took, back in the late 90s, they took laptops and GPS receivers, and they connected those things together with the cell network in Mexico for some IP data traffic. And they enabled each of their cement trucks in this way. This is thousands of dollars of equipment per cement truck in this one region. And what they did was they said, you know, we know roughly how many orders we get a day. And we're going to make sure we have trucks geographically spread out. And what we're going to do is link incoming orders to trucks already in the field. We're going to pre-supply. And because we know, because we have that GPS technology built in, we can route the most efficient truck to the most efficient spot at the right time. And instead of having orders delivered 5 hours later, they can actually deliver orders within 30 minutes. And that's a tremendous change in how they ran their operations. And the business processes involve, of course, supply chain and fleet management, but they also did some sales and accounts receivable. They mapped in a little bit of the information from accounts receivable so that when incoming orders came into the ops center, they would check and make sure their customer had paid out before they okayed and approved the order, because the orders happen so fast. So they implemented this technology, and they turned around a struggling business in a remote area of Mexico. And what happened was that they did imply significant cost, and this is millions in terms of both hardware and in terms of building out the solution. But they received fantastic benefits. Their average delivery times dropped from 3 hours to less than 20 minutes. Their fleet size to deliver the same amount of cement to their customer, they reduced that by 35%. And those are trucks, and those are very expensive trucks. And their just-in-time delivery model changed their commoditized status. So it wasn't just a load of cement delivered at whenever. It was, well, I can be there in 30 minutes, and I can meet your production schedule, and I can keep your project on track. And these are multi-million-dollar infrastructure build-outs that cost a lot of money. They took that model, and now CEMEX is one of the global leaders in cement supply, and that's across Asia, Europe, and the Americas. And at the time, their motto was, now the concrete is faster than the pizza. And that's pretty funny, because they were saying that they were better than Domino's. So we've gone over a few technologies, and we've gone over the impact of several case studies on these technologies. But I would like to spend a couple of minutes discussing Pactera. So at Pactera, we have a tremendous technology baseline. And what that means is we've got experience and skills in developing from the hardware platform up to the application platform. We're a global leader in quality assurance, and we're also tremendous at user experience design. So when we take these baseline technologies, we can help you innovate for your business today. And I'd like to thank everybody very much. If you have any questions, please ping us online.
Thanks, Jeff. We're running out of time for questions, so you will all be receiving a follow-up email with Jeff's contact information if you would like to discuss further about any of these mobile topics. Also, the recording of this webinar will be posted to our Pactera US YouTube page later on today if you would like to see it again. So with that, I'd like to thank you all for joining our webinar today. Hope you have a great afternoon.